Hello everyone, welcome back to my channel. So today we'll be discussing about the third case. So when the force exerted by a jet on stationary curved plates. In the previous two classes, we have already discussed about what will happen when the force is exerted by jet on a vertical flat plate and another one, the plate is inclined with the jet with a certain angle. So this is our third case, and when we are talking about the stationary curved plate, it can have three cases. One, when the jet strikes the curved plate at the center. So here you can see this is the fixed curved plate and the jet is striking at the center. There can be more two cases when the jet will strike tangentially at one end, when the plate is symmetrical about the x-axis and the plate is asymmetrical about the x-axis. So we'll have a very brief discussion about all the cases. Here you can see when I am going to analyze it. So the initial velocity of the jet coming out from the nozzle, with the nozzle is fitted with a pipe, right? So the initial velocity of the jet is basically capital V, right? Okay, so now let's go and see. So the jet, after striking the plate, so the jet is striking at the plate. In this case, it is striking at the center of the fixed curved plate, right? So after striking, it comes out with the same velocity. So you can see it's coming out with the same velocity, which is also V, assuming there is no loss of energy due to the impact of the jet in the tangential direction of the curved plate. And further, we can resolve this velocity, right? If we want to see the direction of this velocity V. So if we want to further resolve it, one will be V cos theta and another one is going to be V sin theta. That the velocity at the outlet of the plate can be resolved into two components, one in the direction of the jet and the other is in the perpendicular direction of the jet. So component of the velocity in the direction of jet is negative V cos theta. So when I'm saying that the component of the velocity in the direction of the jet, I'm saying it is negative V cos theta. Why? Because this direction is 180 degree apart from this direction, right? So they are actually in the opposite directions. So that's why we are taking this negative sign in front of the component of velocity in the direction of jet. And component of the velocity perpendicular to the jet is V sin theta. Over here you can see it. And we also know that how to resolve this components of this velocity. Force exerted by the jet in the direction of jet, we can calculate it like that Fx equal to mass per second into v1x minus v2x. So by v1x I mean the initial velocity in the x direction and v2x is the final velocity in the x direction. Alright, so now you can see that the initial velocity v1x in the direction of the jet is basically v, and the final velocity of this velocity tangentially coming out from the fixed curved plate is basically negative V cos theta. So I can say that this is my V2x. So V1x is V and V2x is equal to minus V cos theta. And this theta is basically this theta. So this is what we have written here, that the V1x is equal to V and V2x is equal to negative V cos theta. So now if we want to find the value, Fx is basically mass per second, that is m over dt into V1x is basically V and V2x is minus V cos theta. So I am getting m over dt into V plus V cos theta. And here we know that m over dt is basically equal to rho q, or you can say rho av, right? Here this rho is the density of the fluid that is coming out. In this case it is water, so the value will be 1000 kg per meter cube. And this q is the discharge rate, you can say. So this is basically meter cube per second, and this a is the cross section area of this jet, and this v is the velocity at which it is coming initially. So these are all the things. Now let us see that what is going to be the force exerted by the jet in the perpendicular direction of jet, which is Fy. So if we want to find the value Fy, all right, so Fy is going to be the same thing. Fy is equal to m over dt, which is the mass per second or the mass flow rate, I can say, into v1y minus v2y. So what is this v1y? Initial velocity in the y direction. V2y is the final velocity in the y direction. Here, from here I can see that in the x direction the velocity is v. But what about the velocity in the y direction? Here the velocity is basically 0, because if we want to find a component of this velocity v in the y direction, that is going to be 0, as the angle between them is 90 degree. So if you want to find a component of this velocity in the y direction, I can say that is v cos 90. The value of this is basically 0. So we are not getting any component of the velocity in the y direction when it is entirely overlapping on the x direction. So v1y is equal to 0, and v2y is basically v sin theta. How? See, from here it is v sin theta. right? So this is the final velocity in the direction of y. So see, both of them are in the y direction. So if we want to find the value, we can just simply write negative rho a v square sine theta. So why this negative sign is coming here? Yeah, negative sign means the force is acting in the downward direction, right? As we have already assumed that the force is acting in the positive x direction, but the negative sign in the final answer is actually meaning that the force is acting in the downward direction. And in this case, the angle of the deflection of the jet, is basically 180 degree minus theta. See, from here we can very easily have a visualization of this. Now it is the second case when the jet strikes the curved plate at one end tangentially. Here at one end it is striking tangentially when the plate is symmetrical, and the other case will be when the plate is asymmetrical, right? So from here you can see that as the jet is striking at a symmetrical curved plate, so the angle will be equal in the tangential lines. You can see this is also theta, this is also theta. So you can see, let the curved plate is symmetrical about the x-axis, then the angle made by the tangents at two ends of the plate will be the same. As we can see, this is theta and this angle is also theta, which is the angle made by the tangents at the two ends of the plate, right? So we are assuming that the velocity is v of the water and theta is the angle made by the jet with x-axis at inlet tip of the curved plate. If the plate is smooth and we have already assumed that there is no loss of energy and due to the impact, so the velocity of the water at the outlet tip of the curved plate will be equal to v. So outlet tip, at the outlet tip the velocity will be v. So the forces exerted by the jet water in the direction of x and y are, we can find the force Fx. So Fx is equal to mass per second into v1x minus v2x. So here you can see that the v1x is going to be v cos theta and the v2x is basically negative v cos theta, right? So I can say, and mass per second is equal to rho av. So yeah, mass per second is rho av. We have already derived it so many times, and v1x is basically v cos theta. So you can see v1x basically means the velocity in the x direction, the initial velocity in the x direction. V2x is the final velocity in the x direction. We just put the values in. Now we just simplify, we can get rho 2 rho a v square cos theta. So what is the value of v2? v1y is the initial velocity in the y direction, that is v sine theta, and the final velocity in the y direction is v sine theta. So mass per second is rho av or rho q, you can say both, and v1y is v sine theta, v2y is v sine theta, so it is giving you result 0. Now we will discuss about the third case when the jet strikes the curved plate at one end tangentially when the plate is asymmetrical. Here our curved plate is asymmetrical and the jet is striking at one end tangentially. Here we can see that when the curved plate is unsymmetrical about x-axis, then angle made by the tangents drawn at the inlet and outlet tips of the plate with x-axis will be different. At the inlet, the tangent is making angle theta with the positive x-axis, but here it was also theta, as that was a symmetrical curved plate. But this is not a symmetrical curved plate, this is unsymmetrical curved plate. So we will have two different types of angle. If the inlet angle is theta, then we can say that the outlet angle will be phi. It will be a different angle than theta. So the theta is the angle made by tangent at inlet tip with x-axis, and phi is angle made by tangent at outlet tip with x-axis. Now we want to find the value Fx and Fy. Fx is the force exerted in the direction of the x-axis and Fy in the y-axis. So Fx is equal to mass per second into v1x minus v2x. v1x basically is representing the force exerted initially at x-axis. Here we can see that initially at x-axis the force is v cos theta, and finally v cos phi is the final velocity, which is also represented with v2x here in this case. So v1x will be v cos theta and v2x will be negative v cos phi. So we just put the values. Mass per second is rho av or rho q, v1x v cos theta, v2x negative v cos phi. If we further simplify this equation, we get this, and then we can get this, as we have taken v common here. Now we want to find Fy. Fy will be mass per second into v1y minus v2y. Mass per second is rho av and v1y is v sine theta. Here in the y direction, the initial velocity is v1y and that is v sine theta. That is the vertical component of this v, and v2y is v sine phi. If we put the values in, we can get the value Fy. This ends our three cases. Thank you so much for listening till the end.